Right now, somewhere in NASA's facility, the most advanced piece of technology ever built is being assembled. It's going to see things we've never seen before. It's going to answer questions scientists have been asking for centuries. And almost nobody's talking about it. This is the Nancy Grace Roman Space Telescope. And when it launches, it's going to change what we know about the entire universe. Most people have heard of the James Webb Space Telescope. Some of you know about Hubble. But the Roman telescope? It's the one that's going to blow both of those out of the water. And here's the wild part. We're talking about it launching very soon. In this video, I'm breaking down exactly what Roman is, why it matters, and what it's going to discover that could fundamentally change how we understand reality itself. Before we talk about the technology, let's talk about the woman they named it after. Because the Nancy Grace Roman Space Telescope didn't get its name by accident. Nancy Grace Roman was an astrophysicist who worked at NASA starting back in 1955. But here's what makes her story interesting. She was doing cutting-edge space science at a time when being a woman in science was, well, it was nearly impossible. She started as a researcher when NASA was barely even a thing. And she didn't just participate in the space program, she helped build it. She was NASA's chief of astronomy, which means she was the person deciding which projects got funding, which missions moved forward, and which ideas were worth pursuing. Roman was obsessed with one thing: what's actually out there? Not just the stars we can see with telescopes, the whole universe, the galaxies beyond our galaxy, the structures nobody had even mapped yet. She spent her entire career pushing for bigger, better telescopes. She pushed for Hubble. She pushed for the technology that would eventually become the James Webb Space Telescope. But she never got to see those launches. She died in 2016 before her vision was fully realized. So when NASA decided to name this massive new telescope after someone, they chose her. Because the Roman Space Telescope is the ultimate expression of what Nancy Grace Roman spent her entire life fighting for. Okay, so the Roman telescope is powerful. But how powerful? Let me put this in perspective. The James Webb Space Telescope, which is currently the most advanced telescope we have, can see incredibly far into space. It can see galaxies that are 13.6 billion light-years away. It can look back almost to the beginning of time. But here's the thing about James Webb. It has a narrow field of view. Imagine looking at the night sky through a tiny straw. You're seeing incredible detail, but you're only seeing a tiny piece of the sky at a time. Roman? Roman has a field of view that's 100 times larger than James Webb. In a single image, one single snapshot, Roman will capture millions of galaxies. Not thousands. Millions. To put this another way, if James Webb is a microscope, Roman is a wide-angle camera. You're trading some fine detail for the ability to see the bigger picture. And that's exactly what astronomers need right now. Think about it like this. If you want to find a specific house in a city, a microscope is useless. You need to see the whole neighborhood. You need to understand the layout, the patterns, where things are. That's what Roman does for the universe. The telescope itself is massive. We're talking about a primary mirror that's about 2.4 meters across. That might not sound huge compared to some ground-based telescopes, but these are two completely different things. This is a space telescope, operating without the distortion of Earth's atmosphere, optimized for infrared and visible light imaging. But the real power isn't just the mirror. It's the technology packed around it. Roman has instruments designed to do things we've never done before. Advanced coronagraphs that can block out the light from stars so we can see the planets orbiting around them. spectrographs that can analyze the light from distant objects and tell us what they're made of. This is a telescope built for discovery. Not just observation, discovery. The difference is huge. So what's Roman actually going to do? Here's where it gets interesting, because Roman isn't just one mission. It's multiple missions wrapped into one telescope. The Billion Galaxy Survey NASA's going to use Roman to catalog over 2 billion galaxies. 2 billion. Let's sit with that number for a second. Right now, we think we've mapped maybe 200 million galaxies in detail. Roman is going to expand that by a factor of 10. Why does this matter? Because we don't know the universe's structure. We've got pieces of the puzzle, but we don't see the full picture. When you map billions of galaxies, you start to see patterns. You start to understand how galaxies cluster together, how they're distributed, how the universe is actually organized. This connects to something called the cosmic web. Galaxies aren't scattered randomly through space. They cluster together in filaments, with massive voids in between. It's like the universe has its own architecture. Roman is going to map that architecture in unprecedented detail. The dark matter and dark energy problem. Here's a mind-bending fact. 95% of the universe is made of something we can't see. 68% is dark energy, which we don't understand at all. 27% is dark matter, which is completely invisible. Only 5% of the universe is made of normal matter, the stuff you can see, the stuff you're made of. Dark matter is especially puzzling because we know it's there. We can see its gravitational effects. We know it's holding galaxies together. But we can't see it directly. It's like having an invisible hand moving things around. Dark energy is even weirder. It's actively pushing the universe apart, making it expand faster and faster. And we have almost no idea what it is. Roman's going to help solve this by mapping billions of galaxies and studying how their light is bent by gravity as it travels toward us, something called gravitational lensing. Roman can map the distribution of dark matter. You can't see dark matter, but you can see its effect on light. Roman is going to create a 3-dimensional map of dark matter throughout the universe. For dark energy, Roman is going to use a technique involving supernovae. When certain stars explode, they reach a predictable brightness. By measuring how bright they appear from far away, we can figure out how far away they actually are. By studying thousands of these supernovae across cosmic time, we can understand how the universe's expansion has changed over time. And that tells us about dark energy. Exoplanet Discovery Roman is going to find thousands of new exoplanets, maybe tens of thousands. We've already found over 5,000 exoplanets, but Roman is going to completely change the game. Most exoplanets we found are detected through indirect methods. We watch a star, and we notice it gets slightly dimmer as a planet passes in front of it. It's clever, but it's limited. Roman has a coronagraph, a device that blocks out a star's light so you can see the planets orbiting around it directly. Roman is going to actually image exoplanets. You'll be able to see them. And not just any exoplanets. Roman is specifically designed to find Earth-sized and larger planets around nearby stars. The kind of planets that might be habitable, the kind of planets that might have life. Think about what that means. For the first time, we're not just discovering exoplanets. We're starting to map what's actually out there in our neighborhood. How common are Earth-like planets? Where are they? How many of them could potentially support life? Supernova and transient astronomy Roman is also going to be a discovery machine for explosive events. Supernova, gamma ray bursts, neutron star collisions. The universe is full of violent, brief events that we barely understand. The problem is, these events happen and disappear before we can study them. You have to be pointing the right telescope at the right place at the right time. The odds are terrible. Roman's massive field of view changes this. It's going to be continuously scanning the sky. When a supernova goes off, when a neutron star collision happens, Roman will be there watching. We're going to catch these events in real time and study them in detail for the first time. This isn't just about the spectacle of explosions. These events tell us about the fundamental laws of physics. They help us understand how matter behaves under the most extreme conditions in the universe. Let's put Roman in context. How does it actually stack up against the telescopes we already have? Hubble launched in 1990 and it's still working. It's done incredible science, discovered dark energy, helped us measure the age of the universe, revealed the true scale of the cosmos. Hubble is a workhorse. But Hubble is old technology now. Its mirror is smaller. It primarily sees visible light, which means it's limited in what it can observe. It's also in low Earth orbit, which means it's affected by Earth's atmosphere to some degree, and it has a limited lifespan before it eventually falls back to Earth. Hubble is still useful, but it's fundamentally limited by its age. James Webb. James Webb is next level. It launched in 2021, and it's been absolutely revolutionary. It can see further back in time than Hubble. It specializes in infrared light, which allows it to see through dust clouds and observe the earliest galaxies that ever formed. But James Webb has a problem. It's slow. Its field of view is tiny. If you want to observe 2 billion galaxies, you'd need James Webb running for hundreds of years. James Webb is designed for deep dives, looking at specific objects in incredible detail. Roman is the survey machine. It's built to map huge portions of the sky, quickly and efficiently. It has James Webb's infrared capability, but with a field of view 100 times larger. Think of it this way. Hubble is your baseline. It sees visible light over a moderate area. James Webb is your magnifying glass. Incredible detail, but a tiny view. Roman is your wide-angle lens. Still incredibly detailed, but covering an enormous area. They're not competing with each other. They're complementary. James Webb finds the interesting objects. Roman maps the broader universe. Hubble provides continuity and backup observation. In fact, Roman is going to feed targets to James Webb. Roman will say, "Look at this part of the sky. There's something interesting here." Then James Webb can zoom in and study it in detail. It's a perfect partnership. Here's the thing about big space missions. They can feel abstract. They feel like they're just for scientists and astronomers. But this is different. When Roman launches and starts sending back data, we're going to learn things that fundamentally change how we understand reality. We're going to find habitable exoplanets. We're going to understand dark energy better. We're going to see how the universe is structured at scales we've never observed before. This is an ancient history. This is happening now. NASA is finishing up Roman right now. The plan is to launch it within the next couple of years. Your lifetime. You're going to see the first images from this telescope. And when we do, when Roman sends back those images of billions of galaxies, of planets we've never seen before, of the invisible dark matter web holding the universe together, that's going to be a moment. That's going to be the kind of moment people remember. Here's the deeper thing, though. Roman represents something important about human curiosity. We've built this incredibly advanced piece of technology not because we have to, not because it makes us money, but because we want to know. We want to understand the universe. We want to answer the biggest questions humans have ever asked. That drive to explore, to discover, to push the boundaries of what's possible. That's why Roman matters. Not just the science, the spirit behind it. If you found this interesting, hit subscribe and turn on notifications. When Roman launches and sends back its first images, I'm going to break down what we're seeing and what it means. This is going to be one of the biggest astronomy stories of the next decade. Drop a comment down below. If Roman could discover one thing about the universe, what would you want it to be? Dark energy? Habitable exoplanets? The structure of the cosmos? I'll see you in the next one.